Have you ever wondered how smart streetlights know exactly when to turn on at a dusk? Well, it all comes down to a tiny, inexpensive component, the Light Dependent Resistor, or what we call it, the LDR. Hello everyone and welcome to our Laboratory 2 video presentation. I am Abdulrahman Al-asbahi and joining me today are my group mates, Chad Zimin and Kok Shaukit. Today, we're exploring the calibration and sensitivity of an LDR. Our main objectives are to relate the LDR's electrical resistance to surrounding light intensity, calculate its precise sensitivity, and analyze its characteristics to see how effectively it performs in dynamic lighting environments. To explain how we set this up, I'll pass this over to my friend Chad Zimin.
Thanks, Abdulrahman. To test the LDR, we built a data collection system using an Arduino Uno microcontroller and a voltage divider circuit featuring a 10 kΩ pull-up resistor. For our control light source, we used a 240-volt light bulb connected to a dimmer. Our methodology involved 4 systematic steps. First, we uploaded our C++ code to the Arduino to read the analog voltage and open the serial monitor. Second, we gradually adjusted the dimmer to change the light intensity. Third, we measured the actual light intensity using a smartphone lux meter app, ensuring it was perfectly aligned with the sensor. Finally, we recorded the voltage and lux readings across 10 different intensity levels to get a comprehensive dataset. Now, Shaukit will take us through the data.
Thank you. Our data reveal a very clear inverse non-linear relationship. At a low light intensity of 2170 lux, the LDR resistance was extremely high, over 7300 ohms. But as we increase the brightness to over 41,000 lux, the resistance plummets to just 460 ohms. When we plot on this graph, the steep drop at the beginning shows us that the LDR is incredibly sensitive in dim environments. By calculating the change in resistance over the change in lux, we determine the LDR sensitivity to be negative 0.173 ohms per lux. However, as the lights get very bright, the curve flattens out, indicating the sensor reaches a saturation point and become less responsive. Physics explain this perfectly. Incoming light photons transfer energy to electrons in the semiconductor, filling them up and dropping the overall resistance.
To conclude, our experiment successfully confirmed the nonlinear inverse relationship between LDR resistance and light intensity. The Arduino setup proved to be a highly accurate and stable platform for real data time acquisition. Knowing that an LDR is highly responsive in low lux levels but saturates in bright level, we leave you with the question to think about. How does the specific sensitivity profile affect the practical use of LDRs in automatic street lightnings? That was all. Thank you for watching our presentation.